welcome back to my channel, and today we will together solve the daily LeetCode problem. For our today problem, we have the problem about the implement the router, and for a router we are given the things like we have the source, we have the destinations for, and we have the timestamp for each packet, and then this package will go to the router, and then we have the router here, and then this router it will be in the style of the first come first serve, which is the FIFO, and then like we need to design the data structure for the router. Yeah, so however, like the difficult thing, I think that it is from the get count function. And then for the get count function, it means that like we are given a destination, and this destination it will associate with an array of the timestamp. That is an array of the timestamp. Yeah, and the difficult thing is here is that we need to count how many kind of the events or like the packages in an interval. Let's say that in here, what if we have the timestamp, yeah, we have the destination 5, and it will have a lot of the timestamp, for example like 90, 95, 97 and 100, for example. Okay, so you can see that in here like the timestamp is in the shorted order, and then so we can see that like if we want to, for example, if we have the find the number of the packages in within the interval from 94 to 97, this one is inclusive. It means that it also contains the number 97 as well, and so we need to do something here. We can see that if this array, if this one is shorted, and then we can have very good approach with the n log n or something to, or like the just log n to find it efficiently, because like we don't need to count how many number lies within this range. We only can check for the lower bound and the upper bound of this range, right? And then it means that we only care about the index, and then we can get the subtraction between the low and the high index. For example, this one is the lower bound, this one is the upper bound, and then this one is the high, for example, and then we just need to subtract the low from the high, and then somehow we can get the result. Okay, so the question in here is that like how can we do that? And then like we also need to update the timestamp for each destination as well. So we can see that in here, for example, what if I have the new package, and then it will be destination 5 as well. However, like the timestamp, it would be like 98, for example. And then so you can see that in here, the simplest way in here is that we can find by iteratively look through each element and find the positions of the 98 in the array, and then insert the 98 to here, right? And also let's say that we have already construct the array after adding a timestamp, and then that would be 5 like here, and then we have the 90, 95, 97, 98 and 100. And how can we find the index associated with this interval? And then so we have an approach to use the binary search, and then with the binary search in here we can search for the lower bound. For example, like in here we can search for the 94. Let's say that this binary search will do the things like we will find the number which is greater, find the first number which is greater or equal than 94, and then so what is the first number equal or greater or equal than 94. So and we return the index. What is the index here? That is the 1, right? Okay, so we can do the very similar thing for the 97. However, for now we will relax the conditions that like we only find the first number which is greater than the 97. Okay, so what is the index of the first number which is greater than the 97? That is the 98, right? And what is index? That is like 0, 1, 2 and 3, right? And so in here this one is our height, right? and this one is like our lower bound, and then we need to subtract the high from sorry, the low from high, that is 3 minus 1, that is equal to 2, right? So it means that we can find this section in the arrays. Yeah, so I think that today's problem is not too difficult. However, like we will teach us how to use the existing packages in the Python or Java effectively. Yeah, so it is difficult because of the implementation aspects, I think. Yeah, so just let's do it together. Right, so here, so for now, because like we have the first come and first serve, and then so I will typically get the queue, the DQ, right? And then for the binary search, I think that you can implement it by yourself. However, if you want to save the time, typically in the interview or in the I mean weekly contest, and then you can use the bisect library, and then in here it will save us the things like it will have the bisect left and the bisect right. Yeah, it will help us to, for the bisect left, it will help us to find the number which is greater or equal than the given number in here. However, the bisect right will help us to find the number which is greater than the given number in the array. So here, like that's why we have the bisect left and bisect right. And for make the code neat and clean, and then somehow we can use the insert, right? We don't want to write the things like the for loop for this, but I think that it is still okay. But we also can use the, in the bisect, it also have the insert function, and then it can help us to do that. Yeah, okay. So for now, if we init and then we have the packages, this one, that would be the DQ. Yeah. And so another thing is that like I will transform the self capacity, that is equal to the memory limit, because like we need to check the memory limit as well. And then so for the things like to store the array in here, for example, this one is the destination and this one is the associate the array for the timestamp for the given destination, right? So in here, let's say that this one is the destination to time, and then we will initialize it as the hash map, and then we need to have another hash set in here like existing data to check that whether data is in the is already in the queue or not, because like in here, if that is in the queue and then we need to perform some actions. Yeah, so that is the things for our init function. And so for the add package, and then so here like we can see that we can construct the key that is equal to the source, and to the destination, and to the timestamp as well, and then we will look up this key if key in the existing data, and then we don't need to do anything, we just simply return the false, right? And otherwise, like if the self we will check the capacity. So it means that if the capacity is full, and then it means that we cannot accommodate any kind of other packages, and then that is will be like 0, right? We have no capacity for that. Yeah, so if this one, and then like we need to remove the out this package in our queue, for example like this one, the out package, that would be equal to, we will pop it out from the queue, and then in here like we just get the pop left. Indeed, like in here like you can use the list for simple, and then just like pop 0. If that is the list, though, you just need to pop 0, right? Get out the index 0. Yeah, so in here like we will get the source, destination, and the time, and in here like that would be like the old package, of from index 0, and in here that is the package 1, and here like that is the 2. Okay, so we got it. And so for now the first task is that like we need to remove the old data, right, from the existing data structure we have already defined in here. Yeah, so to remove this one, and then like we can just simply remove it from the existing data first, and then so self of existing data, it will be it will remove the things like we have the source, the old source, right, the old destination, and the old timestamp, right. We define it as unique by using 3 components. Yeah, so for now we also need to remove the timestamp in the old package, right. So this one is a little bit tricky. So it means that like in here, because let's say that this one is a sorted array, and then so we also can find the positions of the 98 by using the binary search, right? So it will be more efficient. Otherwise, if we just like loop through for each element step by step, and it will take us on, right? So here like we can do things like the timestamp, time index, for example, and then it would be equal to the bisect left of we need to given an array, and that is the array, our array is like the self to destination of the old destination, and we will given the timestamp, right? And then when we know the index of the timestamp, and then we will remove it. So here like with self dot dash to time of t, we will pop the time index, right? We will pop it out, and then so because like we have already removed one element, and then we will increase the capacity to 1, right? Okay, so for now let's say that this is the special case, like when our capacity is 0, and then like in here we can like because our capacity is increased, and then like in here we can accommodate a new element, right? Yeah, so to accommodate a new element, and then so firstly we need to check that if the in here like we will add new package, and then so how can we add a new package? And then firstly we need to add it into the package that append, and then that would be like the source, the destination, and the timestamp, right? And in here like if the we need to existing data as well, we need to update it, and then we need to add the key. We have already defined it here, right? Okay, so we need to check that if the destination, I mean that we need to check this key that is in the hash map of this one or not, and then like if the destination is not in the set dot dash to time, and then like we just need to get the set dot dash to time of d equal to the timestamp, right? Okay, otherwise we just need to update it. That's 2. So in here like we can use the insert function to insert the one element into its position. So yeah, instead you can write the for loop in here. So we in here like we can use the insert and self dot dash to time, and then we can have the destination, right? And then we will insert the timestamp of the new data int, and then so for now we will get the self.capacity. We will minus this to 1, right, because like we updated, and we return the 2. Okay, so what if we forward the package, and yeah, so this one is the packet, not package. Okay, so yeah, I think that the name in here is yeah, it is not good name. So yeah, yeah, this is typos. Okay, so not good naming convention. Yes, this should be packet. Okay, so yeah, just let's say that, let's assume that the name is correct, and then so we need to do the forward. So if we I means that if the if our queue is empty, and then like we just need to simply return it with the empty array, because in here like we can see that if the forward package, and then like yeah, if this one is empty, and then we just need to return the empty array. Otherwise we can do something like we can get the package, it will be equal to self dot, okay, so self dot packages dot pop left, right? And then so for this one, and then we also get the source, the destination, and the time, and then it would be like the package 0, package 1, and package 2. And so for this one, we should we will do the similar things, like we can find the position of the timestamp in the in the dash to time in here, and then like we will remove it from the array, right? We just need to remove it from the array. Yes, so we can we can remove it from the array, and then so we also need to update the existing data as well. Yeah, so to remove it from the existing data in here, like we can remove it by this one, and then so when we forward the package, we will increase the capacity by 1, right? And here like we can return the packet. Okay, so this is for our forward packet. And then so next for yeah, so here like for the implementation of this one, you can see that like firstly we need to check that is the destination. If it is not in the self dot the dash to time, so it means that it is not in the destinations in the router, so we just need to simply return the 0. And then what else, and then we can find the upper bounds, that would be like the bisect right, right? Because like in here we will expect to see the value, the index of the value which is greater than the given value. So here like we will work on the self dot dash to time, and then given array is that for the destination, and then the given value is the end time, right? And then so another one is the lower bound, that would be the bisect right, bisect left, and then we will pass the dash to time it for the destination, and then this one should be the start time. Okay, so we just need to return the high minus the low, right? Okay, so in here we have the local variable t, right? Okay, so in here like it means that in here I have something, this one should be the destination. Okay, right, most of the people has the same solution like me. Yeah, so we need to optimize this through the day. Yeah, so again, so thank you so much for watching my video, and if you like, and if you want to give me more motivations for you guys in the future, please give me a comment, like, or subscribe. I appreciate about that. And yeah, again, thank you so much for watching my video, and see you next time.